Sir, please tell me whether my PPT is visible and the slides
Yes.
are clear.
Yes, ma'am, it is visible.
Okay, thank you so much, sir. So good evening, dear participants. So in this session, we are basically performing analysis and detection of Android malware. So this is the agenda of this session. First, we are going to perform malware analysis with the help of reverse engineering, which is known as static analysis. Then we are going to perform detection with traditional machine learning algorithms such as neural network. Then we are going to detect the same malware with advanced technology such as large language models, that is LLM. And then I'll be showing hands-on practical with all of you. So let us start with malware. Let me just okay. So malware is a malicious software, and I guess all of you are studying malware from this FDP, and you all know that malware can be in any form, Trojan, virus, spam, anything. And malware can not only infect your laptops or your computer system, it can also infect your smartphones as well as Internet of Things devices which are surrounding us. For example, your smart washing machine, smart AC, and everything. So it is very important to analyze and detect these malware. And in this session, I'm focusing on Android malware. That is a malware which infects an operating system that is known as Android operating system on your smartphones. Now, just a quick introduction about Android operating system. We all know about it that in our smartphones, we use this Android operating system, and it is the most widely used operating system worldwide. If we look at into the statistics, we'll see that approximately 75% users use this Android operating system. And that is why it is very popular among hackers to attack, basically, because it has a large surface area, large population. So hackers use some techniques or they manipulate these APK files to attack or to hack your smartphones. Now, what are these APKs that you can see on the screen? APKs are Android package kits. For example, whenever you download any software, it has an extension, if you remember, .exe, executable files. So similarly, when you download these apps in your smartphones, if you have observed, these have extensions .apk that are Android package kits. Now, in your smartphones, whatever apps you are using, whether it's related to your social media accounts, education, or the application that are already there in your smartphone, these all applications are .apks. Now, if you just go to this news section and just write Android malware in your Google, you will see a lot of news related to Android malware. Millions of Android devices at risk from new malware threat. New version of Android malware infects millions of devices. Your Android phone will soon warn you about this, and so on. You will see that continuously news are definitely coming from around the world that this kind of malicious apps have appeared, even also in Play Store. If we see that, okay, Play Store is fine, bouncers are there to remove these malicious apps, no, there are some malicious apps that still resides there. So we should be very careful when we are installing any applications from Play Store or any third-party app store. Now, talking about research, definitely we all are here to publish a good research paper in SCI transactions, definitely. And for that, these are the steps, and I'll be following the same in this session. So first one is definitely browsing. Go to Google Scholar, search about Android malware paper, and focus on a specific kind of malware. For example, there are various malware that you will find: spyware, adware, ransomware, a lot of malware you will see, but focus on a particular kind of malware instead of going to generic. You will find research papers where you can request them to give you the data set. If they will give you, that is fine. Otherwise, you can collect the data set from Kaggle, IEEE Dataport, VirusShare. A lot of websites are there, and you might know about these data sets now because the FTP was going from the past few days. Next step after collecting the data set is analysis, and after analysis you are going to perform detection. And in this session we are going to perform these steps one by one. So let us begin from the data sets only. So first step is to go to Google Scholar, read some research papers, and if you think that okay, researchers have developed their own data set, their own malicious applications, not only applications but executable files also, then definitely you're going to request them by email. Otherwise, you can download malware from virus share, but the drawback of virus share is that you need to download it one by one, one malware at a time. So otherwise, the second procedure is you can write a Python script to automate it. And Kaggle, though we all know about Kaggle that it is famous for data sets and competitions about artificial intelligence. So you can find some data sets there also. But whenever you are doing some research, there are two kind of data set that you will find. One is raw data set and one is already in a CSV file. From Kaggle, you will find this CSV file. If you're writing, if you want to publish a good paper, don't go for this. Go for the raw data set. Because CSV file with already the features are already there, everything is done. You only need to apply machine learning. Not much work has been left for you. But yeah, if you actually want to publish good research paper, go for raw data set. Now, what is raw data set? These are raw data set. That is the APK or executable files. That is the software which are in the form of a package kits, zip file, or we can say executable file, anything. So that is the raw data set, because you will explore so much, you will find lot of features from there, and you can even contribute to the literature by adding some novel features, by adding some new techniques or feature selection algorithms and so on. So that is why I recommend all of you to go for raw. Now that's all for the introduction of malware and the steps that we are going to perform. Now let us begin with this malware analysis. Now before starting this malware analysis, I want to know from the audience, from the participants, have you done this like Android malware analysis before in this FDP?
Yes, ma'am. They have gone through some of the session where particular
Okay.
to this Android malware.
And which tools have you used? Can you name
So
any
most
tools?
so participants, if you have followed the session, you may name the tools. Some that reverse engineering tools were there. Actually, I'm
Okay.
not
Okay,
working in
okay.
this Android field, so
Okay, sir.
I didn't
Okay.
remember. I able to recall.
No issues. Okay.
So
So
yes, it was AIDS
yeah,
some
please.
tool.
Okay, fine. So why I was asking, because I don't want to repeat the same
Sure,
software
sure,
because
ma'am.
I
Yes,
have.
ma'am. Yes.
Okay,
Thank you.
so because AID I'm not going to basically use in this session. So let us start with the malware analysis. The first thing is malware analysis is reverse engineering. So we all know what is engineering, the art of making things. We are making a calculator. Now what is reverse engineering? Going in the reverse direction. Now we are opening calculator, checking what are the wires being used, what are the batteries, microcontrollers, everything. So that is process of reverse engineering. So in this term, in software term, we can say disassembling a software program. That is, someone has nicely written a program. With the help of compiler, we know that executable files have been created. If a compiler is there, you have compiled a program. So a nice executable file created. Now, what these hackers, cyber criminals, what they do, they reverse engineer this. They perform reverse engineering on executable files so that they can check the source code, because otherwise no one can check the source code. If you download any software, for example, for this basically FDP, I downloaded WebEx, so it was in the form of .exe. I cannot check the source code. But what these cyber criminals does, they perform reverse engineering so that they can actually check the source code. It's similar to like just like you unzip a folder to check the contents that are available in the folder. It is similar like in the same way. So we can say that reverse engineering is the process of reversing the packaged file. And why is it so? Because hackers want to reveal the files whatever are there in that particular package. And after recovering, they change some source code to make it malicious. For example, they just downloaded an app, any social media app from from Play Store, for example Facebook. Then they perform reverse engineering. They change few lines of codes, for example permissions, for example admin privileges, for example getting location permission, or if I'm talking about other things, they can add locking code there, so that whenever you download or install that particular application, your smartphone will automatically get logged with a random password that sometimes even cyber criminals don't know because it's a process of algorithm. So this is how the reverse engineering works, and malware analysis team is there. So here I'm talking about authentic purpose, not about cyber criminals. Malware analysis team is there. They perform reverse engineering on Android APKs sometimes to recover the files, and they reveal some information such as the permissions used by the particular app, operational codes, intents, uh, uh, images, resources, a lot of things that we can reveal. Basically, in brief, I'm talking about reverse engineering. You can reveal everything, whatever is there in that particular application, in that particular software. So now we are going to perform reverse engineering. And for that, definitely you are going to download some application. So you can either download from apkpure.com, mirror of Play Store, the application that you cannot find on Play Store. Sometimes what this new generation does, uh, when government bans these applications, TikTok, uh, they were extremely angry. Why is it so? So they download from any third party app store. So I do generally don't recommend to do so, because this is a for research purpose only. So that is why I'm telling all of you, if you want to do practical, you can either download any, a single app is fine, or you can download from APK Mirror or Virus Share, though is very famous. You all of you are familiar with this. You can download any application from there. So from Virus Share, you will be getting malware applications. And from here, you can download benign application, or you can download from Play Store also. Because machine learning works on both. You need good as well as bad examples to train the model. So again, I'm repeating, from Play Store, you will be downloading some benign applications, and from Virus Share, you are downloading malicious application. Now, let me show you how you can download it. If you go to Virus Share, first you need to create an account there. So here you can go to login, and in order to log in, you need to send them an email regarding this, that you are not using it for malicious purpose, you are only using it for research purpose. Then they will just reply you with the credentials. Now here you can write, suppose we are working on Android, you can write Android here and click on search button. Uh, Now it depends on your internet connectivity. You will find applications, but the problem is, if you click here on a download button, you can only download one malicious application at a time. I think my internet is a little bit slow. Otherwise, it will show all the samples, malware samples available for Android operating system. So that is why I had already downloaded two APKs. You can see on my screen, 1.apk, 2.apk. I hope my screen, this part is also visible that I'm doing, because I've shared the complete screen. So any participant, could you please give me a feedback? Visible? Okay, fine.
Yes, yes, ma'am. It is.
Okay, thank you. Let's go ahead now. So let's do the practical now. So the tool that I'll be using here is the APK tool, and you can easily download the tool from here. I'll be sharing the PPT after my session. You can download the APK tool. And one more thing, whenever you are downloading APK tool, the batch file is available there on the website. I recommend all of you to download uh, the batch file also. APK tool. So So here you can see the batch file is there, wrapper script. Please copy this wrapper script in your notepad plus plus or notepad, and you have to keep there wherever you are downloading your APK tool, and you can download the latest version of APK tool from here. Now I have already downloaded the APK tool, and batch file I've stored here in my .txt file. So let's see the next step. Now what I have to do, I need to run this tool. So the step to run the tool is, first I need to go to the drive where I have placed that APK tool. And after this, I need to write few lines. For example, I need to write Java. So space hyphen jar space the name of the tool dot jar. So definitely, because Java is being used, it means you need to install JDK, JRE, and restart your computer after installation. Then only you will be able to see the output. Otherwise, there might be some error. So because we need Java because it's a jar file. So Java space hyphen jar apk tool dot jar. If it is working fine, then it will show you the manual, the procedure step by step. The next step would be you need to write Java hyphen jar apk tool dot jar D. D means D stands for decompile. That is, I want to decompile my APK. It can be any APK. You can. It might happen when you download any APK. The name is too long, so you can shorten it by giving it a small name. For example, here you can see in my system I have given a very short name .1.apk, because generally a hash name is given to each APK whenever you are downloading it, and it's very long. Next is, after decompilation, we are going to build uh, that particular app so that we can see each and every folder. For example, smally text files, resources, libraries, everything. So let's do the practical. So I'm writing here CM. Okay. I'm opening my command prompt, and I placed this APK tool in my E drive, and let me copy paste the exact location. CV. Fine, I'm here. Now I need to write Java hyphen jar. The tool name was apk tool dot jar. That's it. I can see the manual, it means it is working fine. Now I'm going to decompile my APK, and as I already shown you in my screen, the name was one.apk. So let us do it. Java jar apk tool.jar d1.apk, it is fine. Okay. Now you can see here that here so I guess I'm getting some exception because I guess the tool I'm using, the version is old. So let me download the latest version of APK tool. So it is, this one is the latest. Let me remove the old version of APK. Fine. Now I'm decompiling one.apk, and I'm building one. Again, I'm getting some exception, might be that because of this version that I'm using right now. but earlier it was working fine. So let me show you some folder that was created earlier. Let me copy paste those here. So here you can see that this one folder, you can see it will be created after this. Right now I'm getting some exception or errors. That is because of might be the version problem, no issues. But yeah, I guess the previous version from this version will be, it will execute and you will be able to see this folder. Now, what I want to say from this, it was earlier one.apk file. Now, when you decompile it with the help of APK tool, you will see a folder with the same name, that is one. And inside one, you will see a lot of files. For example, here you can see Android manifest XML file. So if you have attended any Android FDP earlier or did the reverse engineering, so can you tell me what is placed in this Android manifest XML file? Yes, anyone please? What is placed there in Android? That is, whenever you are downloading any application, there is a manifest file. What is there? Permissions. Yes. So in here, you can see all the permissions that a particular app is going to ask from your phone or from you users, that is compulsory for the Android developer or the programmer to mention the same in this manifest.xml file. So you can see here that internet permission, access, network state, read phone state, receive, boot state, and completed. These four permissions are mentioned here. It means that definitely that app is particularly going to ask while installation. Besides this, you will see Smalley code also. That Smalley code you cannot actually understand easily. Uh, but with the help of machine and deep learning algorithm, you are going to extract some operational codes from this Smalley code, and that operational codes you can give to a particular machine learning algorithm, and from there also you can detect this. So besides this Smalley code, you will see a lot of images and other things. But the problem here is that here you will see the DEX file. DEX file itself is not a problem, but the problem is you cannot read it or you cannot open it. So that is why there are some other reverse engineering tools that you can explore further if you are interested. So these are these tools, dex2jar and jdgui. From dex2jar, you can convert your dex file to the jar files, and with jdgui, you can basically convert it into .java and you can open it, those Java files in here. So coming back to these apps, you can see here that this was a particular kind of malware that I've used in my research. This is a ransomware file. And here, if I go to here my dex file, you can see a folder classes dex2jar.jar. So this is the tool that I've used to convert dex file to jar file. And here I you can see here that I have Java files also. So when I open it, you can see a lot of Java code which was initially written by a programmer, or it can be manipulated by a cyber criminal or a hacker. So these are the Java files. Now, why I'm explaining this to use these many tools, because if you are seeing this different kind of files, you can extract different features. For example, from Java, you can extract any malicious function that has been used. If any encryption technique has been used, AES, RSA, you can extract the same. If any encoding technique is used, you can extract the same. If some locking functionality has been used, you can extract the same. So that can be used as an input to machine learning algorithm, and those features can become novel. So that depends on your programming skills, how you are analyzing the code, and what are the things that you are actually differentiating from benign application. That okay, after analyzing the code, I've seen that this has been used in malware, but this has not been used in benign applications. So that is the beauty of reverse engineering that you have seen here. And if you are just downloading a CSV file from internet, then you cannot explore these features yourself. You're just using built-in features. So now let's come back to the PPT where I have left. So you can see here, after this building this PUBG file, uh, after decompilation, I got this PUBG folder and this share it folder. Earlier it was in the form of .apk. Then when I open this Android manifest file, you can see a lot of permission. A permission list is there. These are the permission that that particular application was asking from the user. And if we look at permission, there are some dangerous permissions also that we should be very careful whenever we are giving this application. For example, here location permission whenever we are giving, because generally if an Uber app is asking or Ola app is asking for permission, that is fine. But if you're downloading some another application, for example, dictionary, why it is asking for that location permission? So we need to be very careful about these permissions, specifically about your camera and your call phone. Here also you can see these permissions also come under dangerous permissions because they are using your storage, they are reading your storage and phone state also. You're reading your SMS, sending SMS, recording audio, and writing in your external storage that should be used by you only, but they are used by malicious application. That also comes under dangerous application. So these are the basically list of all dangerous application, and we should be very careful whenever we are giving this permission to any particular application. So that's all about in malware analysis part. And one more thing I would like to tell you in malware analysis, that although you got this source code, but you cannot give this to traditional machine learning algorithm. I'm not talking about large language model because that's an advanced concept. We are going to use it. But if you're using neural network, you're using a support vector machine, or any KNN, any algorithm, you're using random forest decision trees, you cannot give these files to machine learning algorithm because ML algorithm is not going to understand it. You are going to use these features and convert it into a form that a machine learning algorithm can easily understand. How? Let me show you. Here you can see the data. Now, for example, I have shown you the permissions in Android manifest XML file. I have converted those features to this CSV form such that machine learning algorithm can understand it. Now, how I converted this? With the help of Python script. So I wrote a Python script and it read my manifest.xml file from each application. For example, here you have only seen two applications, but whenever you're working or doing research, you will see thousands of applications. So Python script will automatically read one by one each file, and they will see, okay, for example, if this particular permission is being used by any application, I will write 1. If this permission is not used by any application, I will write 0. That is what I told. In CSV file, first I will create a header. What is header? Header of all permissions. For example, in Android, there are total 330. That is, I repeat, 330 permissions are there. So I mentioned all applications, all permissions in my header. You can see 330 permissions I have given, except the last column because that's a target column. Now here I have written this is my application number 1, this is my application number 2, and so on. So if application number 1 is asking for any particular permission, there I will mention 1. If it is not asking, I will mention 0. So that means it's a binary feature, 0 1 0 1. Simple. In simple terms, I have this is how I have created. Now for example, this app is also asking for that permission, this also, then I will mention 1. I hope this part is clear. And how I have written this, I have written a code for this. This is the code. You can see here, first I installed all the libraries and given the path I've worked on ransomware. So during my PhD, instead of working on generic malware, I focused on a specific type of malware, that is a ransomware. Now here I've written that, okay, the pattern is this, that is wherever I found this apk tool.yml, go there, go to that location. Now this is my header list. Well, now what is this header list? These are all permissions that Android operating system, there are particularly 330 permissions, and all permissions I have mentioned here, because definitely these are the only permissions that an app is particularly going to ask. Now here I have written the complete code that I went to that particular directory, and after that, uh, I read Android manifest.xml. In that XML file, I searched for uses permission, because here if you see in Android XML file, you will see uses permission wherever a permission is mentioned. So that is why I've written this find all uses permission, because it works like a tree. So XML. So that is why I've used this tree structure. After going to the root, I found this uses permission, and here I've written a for loop that is in uses permission. Wherever I'm finding a permission, it will add to that list, that is permission underscore final. So that I have created here. Empty list is there. So I'm filling it with all the permission that a particular app is asking, and I'm splitting those permission with semicolon. Now, then I've given this CSV file location here, and I'm appending value 1 or value 0 in CSV file. That is, if the header, the permissions written in the header is available in that application, corresponding application, then value 1 will be written, otherwise value 0 will be written. So this is how automatically this CSV file has been created. So that is why, if you remember in the beginning of this session, I explained you that there are two kind of data set that you will find. First, raw data set, that was the APK files, and second one is this CSV file. So it would be better if you create this CSV file yourself with the help of reverse engineering. And this is the only static analysis technique, but there is also dynamic analysis technique in which we run a malware in some sandbox. You must have heard about Cuckoo Droid sandbox. There we run it live, and you will get a lot of network related information also. So instead of downloading this Excel sheet, go for reverse engineering and dynamic analysis process. Now then I opened this CSV file and written the values, and they were all written in a single column with semicolon. Then I split those into values into different columns. So this is how I created this data set, and this CSV file that I'm showing you is only for permissions, but I've also done for other, created the same file for other permissions as well, such as our dynamic features although, but I've created a file. So in this session, I'm only focusing on permissions. Now the last column here, you can see it's all about one and continuous one and continuous zero. It means the top are the malware, and here the bottom ones are the benign. Zero means benign, one means malware. Okay. And here you can see that I have approximately 398 rows. That is how many applications? 398. And 50% are approximately benign, 50% are malware, because we need to make the dataset balance. If it is imbalanced dataset, that even if you are getting a good accuracy, we cannot rely on it. So this is all about malware analysis. That is phase number 1. How many samples have you used for your research work, and what types of classification you have applied? Okay, so I worked on only on ransomware first of all, and I did not find ransomware samples anywhere on the internet, not in any repository. So I read a research paper from China. It was published in IEEE Transactions, and I requested them to provide me raw dataset. I again explained for raw dataset. So they gave me approximately 2000 ransomware applications. I wrote this, let me close this. When I wrote my Python script, no, then I know that first I run those for ransomware applications only. So I make a separate CSV for ransomware, then separate for benign. Then I combined one CSV. So this is how it worked. Next question. Raw means yes. Whenever I'm talking about raw, it means .apk files. Or if you want to work on Windows, it's .exe file. See, the procedure is same. I'm using one tool, you will use another tool. Why I worked on Android? Because I saw less research paper on this or less research work at that time. So that is why I go for Android operating system. Balancing is also a key feature. That definitely your dataset would be balanced. How can we believe that the APK is downloaded from Play Store but not having any malware? Very good question. See, that are known as some, we can say, false positive or false negative. We need to believe. Uh, Definitely, there would be some malicious applications there, but this is how it will work. Or you can do one thing, you can cross verify with virus total, but you need to verify again it one by one. If you have that much time, you can verify from any online repository, is it malware or not. Raw include APK, EX, everything, definitely. Uh, Static analysis, the question I think is not complete. Static analysis. Nayan Kumar Maliji, what are you asking about static analysis? You can ask. Yes, no. In my research work, I used both static and dynamic, both features. That is known as hybrid analysis. But research papers are different. For example, I published one research paper on static analysis, the other is on hybrid analysis. Did you use only permissions as feature or there were some other features? Yes, there were other features as well, not only permission. This is only for this lecture purpose only. But I used intents, I used encryption, I used encoding, uh, I use locking features, malicious functions, so a lot of features that I've used. Okay, so I hopefully I've answered all your questions. If still there is any doubt, you can unmute yourself and ask me. Okay, no question now. So now I'm closing it, the CSV file, minimize it. So now I'm coming to phase number 2. You have done malware analysis, although my session name was incomplete. So I thought let's merge detection also in this session so that, so see, in malware detection, we are going to use here in this session, traditional ML, because you know that ML is day by day mm, um, is expanding so much. New techniques are coming day by days, and recently if you use an algorithm, you will see it will become traditional. Everyone has used it because if you're from any department, civil, mechanical, electrical, electronics, everyone is working on machine learning. So the first thing, going to use traditional machine learning. Then nowadays everyone knows that LLM is talking about LLM racks. So then I'll be moving to LLM. Now from traditional LLM, I in the end now. I chose MLP for traditional ML algorithms, although there are other ML also, but I only chose MLP is being used. So that is why in traditional ML algorithms, I thought let's proceed with MLP. Now, what is MLP? MLP stands for multi-layer perceptron. Just like single layer perceptron is not multi your brain. If we touch something, its thought will immediately come to know and हम अपना हाथ बिल्कुल पीछे कर लेते हैं. So this is, and we give input, it moves in that neurons, forward, back propagation unless the error is being reduced, and then we will get the output. And output can be in any form, whether it's malicious application or benign application, because this FDP is all about malware. So I'm giving example related to the malware only. Now here you can see that artificial neuron in hidden layer uses association and activation function. So first I told you the introduction about MLP, that is multi-layer perceptron. Now before this sentence, let us understand how MLP works. Here you will give some input features. Now what are your features in Android malware? Can you tell me the name of the features? Can anyone name the features that we can give to machine learning algorithm? Yes, I showed you here also permissions, API calls, intents, everything that you have placed nicely in a CSV file after pre-processing, after cleaning the data. There is no empty cell, nothing is there. Hmm, That are your permissions or your features, any features, API calls also, function names also, everything. And here one bias is definitely there. And these features will become as an input to your first layer. To all neurons of your first layer. Suppose there are 5 neurons, it will go to the first neuron. This also will act as an input to the first neuron, and so on, including the bias. Now, with these features, there are some random weights allocated to it. They are, I again repeat, they are random because we don't know how to allocate the weight. We don't know which feature is more importantly used for index location. That is, I want to tell my code, or I want to here write that from this column to this column, these are my features, and that column is my uh, target column. Because I'm using supervised learning algorithm, I need to identify what are my features and what is my target. So you can see here in my CSV file that these are the number of columns. So there are approximately, you will see 330 columns. These are my features. So that is why these are, I have written the same in the code, and this is my target column. So let's come back to the code. I've written here df.iloc. iloc means index location, and in square bracket there is a comma. On left hand side of comma we write rows. On right hand side of comma we write number of columns. So I've not mentioned number of rows because I'm taking all rows. So that is why it is empty. Empty means all rows it will take, only column I have written. Now here I am writing from 0 to 330. I repeat, from 0 to 330. Now remember, ILUC takes one less column. For example, it is not starting from 1, it is starting from 0. Okay, so it will take 0 to n minus 1, that is 329 column. That becomes your 330 column, जो कि मैंने आपको CSV फाइल में दिखाया. Now here I also need to mention what is my target column. So in target column, I'm not mentioning the range. I'm only mentioning the column number. So when you are not mentioning the rate, it will take exact column. It will not take n minus 1. So I've mentioned 330, that is the 330th column. I hope the code is clear to everyone. If you have any doubt or you want me to repeat, please let me know. Now here I've written X, it printed the all features and their values. So when I wrote Y, it has printed, you can see here, the target column. And so it is like a cross verification, whether it's fine or not. Now here, what did I do? So first thing, I imported library. Second thing, I uploaded the data set. Third thing, I told this that these are my features and this is my target column. Now the next step is I need to split the dataset into training and testing, because we know that in supervised learning, machine learning algorithm, we need to train the dataset, since MLP or the multi-layer perceptron is your supervised algorithm. So that is why I have imported train test split from my sklearn library, and from sklearn I called model selection function and imported train test split. Now train test split, here I have written X. Now what was the X? If you remember, X was your number of features. Y was your the target column. I mentioned X. Y. Test size I have mentioned 30. Now it's your wish whether you want to train 70-30 ratio or 80-20 ratio. But the training should be large. For example, I'm teaching you more, but when I will ask question, it would be less. When we when we draft a question paper, we ask less number of questions so the student can complete it in 2 or 3 hours. So testing size, I put 30%. Random state is 0, that is, it should not shuffle it. And this is all. Yeah, and one more thing, if you are mentioning test size, no need to mention train size, because automatically means that training would be rest 70%. Now training testing is done. Now the next thing is importing the algorithm. Now from again sklearn library, it is calling neural network, and then I'm importing MLP because MLP is a kind of neural network. Now you can use any algorithm here. See the above code and the below code, everything is changed. The only thing is you only need to change the name of the algorithm. Now here from SQL and neural network, you imported MLP classifier, and here you are mentioning your hyperparameters. That okay, I want hidden layer size 2. Why I have written only 2? Because data set that I've shown you is very less. If you have large data set, go for large number of hidden layers. Maximum iteration and activation function, I'm using 10h. Now that depends, you can use ReLU also, or the type of any ReLU activation function. Okay. Now here, one important thing that I would like to tell you, that hyperparameters, although it is hit and trial basis, you can use change and you will see improvement in accuracy or decrease in accuracy, but you can use some algorithm to automate the process of hyperparameters so that it can be a hint for your research also. So that can become your contribution also, that instead of hit and trial, you have used a particular algorithm for automation of this hyperparameter tuning. Okay. So there are so many algorithms, it is available freely and you can use it. Just write the name and a little bit code, a few lines of code. It will automatically tell you, okay, these are the best hyperparameters, and you will use that and you will get best results. Now then you will train your, now you have imported this MLP classifier. Now you are training your MLP. Now for training, you will use fit, and if you are going to test, you will use predict. Right. Now here you can use fit for training, and out of these four, that is where were these four? These are, these are these four: X-train, X-test, Y-train, Y-test. Now, if you remember here, I've written X, Y. Now, after train test split, it becomes like four. X-train, X-test, that are number of features used for training, and 30% features that is used for testing. Similarly, Y underscore train means the target that is used for training, and Y underscore test means the target value used for testing, or it will not be used for testing. Actually, it is only used for verification. Fine. So, yes, tell me, out of these four parameters that you are seeing here, which two parameter I'll be using for training? I'm repeating again, I'm using MLP classifier, and I have, you can see here, four things: X-train, X-test, which are the features used for training and testing; Y-train and Y-test, that is the last column, target column for training and testing. Which two parameters I'm using for, will I use for training out of these four? I hope you are not tired. It's very Y, X train and Y train. Okay. See, you will use here X train and Y train. Why? Because X train क्या है आपका? These are the features. आपके पास टोटल कितनी फीचर्स थे? ये सारे. बट इसमें से 70, ये सारे एक्सेप्ट दिस कॉलम, ऑल आर योर फीचर्स. अब मॉडल को ट्रेन करना है, वी नीड टू गिव फीचर्स बट नॉट ऑल फीचर्स. 70% फीचर, 330 कॉलम कंप्लीट, बट रोज उसमें से कितनी है? सिर्फ 70%, 70%. फॉर एग्जाम्पल आई हैव 100 रोज, उसमें से 70 रोज आई एम गिविंग एक्स ट्रेन. And I am also giving this Y train. Y train क्या, if you remember this, the last column, target column, but not complete, only 70%. That is few malware and few benign. It will automatically take. Because this is supervised learning. If you are using unsupervised learning, then no need to give this Y column. It will automatically predict. But here you need to give. Because training is just like you are teaching in a classroom. Students को पढ़ा रहे हो. If a student is asking you a question, you are going to answer the same. You will clear all the doubts. You will teach everything. You will explain very nicely. So that is the part of training. So in training, remember, we will give X train and Y train. So this is how the model will train. Okay, now the model will learn, okay, if a particular app is asking this permission, is not asking that permission, is asking this, so it will be a malware. If a particular app is not asking for these kind of pattern, this kind of permission, that means it is a benign. Learn कर लिया उसने. Now it's time for the quiz. Exam का time हो गया. Students will write the answer. So that is particularly test. Okay. You will give question paper to student. Question paper has only questions, not answers. I repeat again, you are giving for testing part, you are giving question paper to the student. Student has to write the answers. So that is your testing. So now can you tell me, training is done. For testing, which parameters we will give as an input out of these 4 parameters? I repeat again, which parameter or parameters we are going to give as an input in testing to the model. Okay, one answer X train. Any other answer? I'm repeating my question again. We are done with training. Training is done with X train and Y train. You have given the features, you have given the labels to the model. Model learns that okay, agar ye pattern hai, this is the output. This is the pattern, this is the output. Now it's time for testing. Yes, we will use test data set. Which parameter? Okay, Y test, X test, Y is much, X test. Okay, so most of the participants are saying X test. But I have seen some responses with Y test also. So whenever we are writing a question paper or giving to the students, we are not mentioning or we do not write the answers. Student will write the answer in the answer sheet. See, it's very important. I want to make it clear to all of you. Testing may we only give questions, student will write the answer, we will check those answers with the actual answers and we will check the answer sheets. So similarly in testing you will only give X underscore test and you will get predicted Y, that is the Y predicted by the model only. ठीक है, मॉडल ने क्या आंसर बताया उसका वो आपके पास आएगा. And then you are going to verify this Y predict with which parameter? Can anyone tell me? Y test, yes. We are going to evaluate, we are going to verify, is it correct or not? And this is how we will give marks to the machine learning algorithm, how much accuracy, precision, recall, F1 score we are getting. So I hope now these things are clear to everyone. X train and Y train. Fit we will use in for training and X train Y train we will give. But for testing we will use first thing predict. And in predict we are going to pass X underscore test only, no Y underscore test, because that will be used for evaluation. So here we will find this Y underscore predict and this is the predicted Y. Now next thing comes is your confusion matrix. We will make, everyone knows about confusion matrix? पता है सबको? True positive, true negatives, false positive, false negative. नहीं पता है? Okay. Then though I need to open my previous PPT. That is with the basic of, here you can see confusion matrix. This is the confusion matrix. So after this evaluating or matching, we need to find some values. Okay, now here carefully please see this confusion matrix because it is actually confusing. First thing is actual and second thing is your predicted. Okay, actual means the actual malware जो आपके CSV file में है, and predicted means, first this thing should be clear to you, that is predicted by your ML model. 0 means benign and 1 means your malware. So predicted 0 and predicted 1 means predicted by your machine learning model, and actual 0 and actual 1 means actually वो जो y underscore test था, if you remember, that was this, and this is your y underscore predict. Now there are 4 things in confusion matrix: true negative, true positive, false negative. True positive means positive as well as true. That is positive आया, इसको positive को sense में लेना, वो medical की sense में. You're positive with diabetes. So similarly, positive with malware. So it was actually malware, and your model has correctly predicted it as malware. That are true positive. True negative means negative, that is benign, actually may be negative, and your model has correctly predicted it as negative. That is why true is written here. I hope these two terms are clear to those who didn't know about confusion matrix. Now the false positive and false negative. Now term says false. Positive hai but false. That is, your model predicted it as malware, but actually it was benign, so it is false prediction. False positive. False negative, your model predicted as negative, that is benign, but it is actually false because actually it was a malware. Okay. So whatever you have predicted, negative or positive, will come here, and true or false, agar wo sahi hai to true, otherwise it will become false. So this is the confusion matrix, and based on those confusion metrics, we calculate these parameters, if you have heard it. Precision, recall, accuracy, F-score, these are very popular parameters that you must have seen in every research paper. We calculate this. Accuracy का मतलब होता है number of correct prediction out of the total number of prediction. How many marks you are getting out of 100? Precision or recall, there is a minor difference. You can see that here false positives are written, here false negatives are written in recall. So that means precision बताता है how many predicted positives out of predicted positive, how many was actually positive. जो मॉडल ने प्रेडिक्ट किए पॉजिटिव, उसमें से कितने सही थे. दैट इज हाउ प्रिसाइज आवर मॉडल इज. रिकॉल का मतलब होता है एक्चुअली में पॉजिटिव कितने थे, चाहे मॉडल ने नहीं डिटेक्ट किए, उसमें से कितने सही थे, कितने एक्चुअली में मॉडल ने प्रिडिक्ट कर पाए. सो समटाइम्स यू विल सी अ मॉडल इज गुड, गिविंग यू गुड प्रिसीजन, मॉडल इज गिविंग यू समटाइम्स गुड रिकॉल, बैड प्रिसीजन. सो हाउ विल यू डिसाइड विच मॉडल इज बेस्ट? यू विल टेक अ हार्मोनिक मीन of precision recall, that is known as F-score. Okay, now I'm coming back to our that PPT. Let me close it. Okay. So I hope this was the code. So this is how we created this confusion matrix between y test and y predict. Remember, y test is the actual y predict is the predicted y. Okay. So you have written very nicely. You imported matrix, and from confusion matrix you got this. And when you write CNF underscore matrix, that is this. You got this confusion matrix. You can see true positive, true negative, false positive, false negative. We have very less few false positive and false negatives. And then you measure the accuracy 91.6, precision 90.4, recall 93.4, F-score 91.9. So this is how you got these values. And these are actually less. Accuracy is not so good. So what can I do to improve the accuracy, precision, recall, F-score? Can anyone tell me? क्या करूं एक्यूरेसी इंप्रूव करने के लिए? फीचर सिलेक्शन लगा लूं, हाइपर पैरामीटर ट्यूनिंग कर लूं. वेरी गुड. एनीथिंग एल्स? Can I improve the features, increase the features also? I can add other features that you already told me. API, data set is already balanced, but मैं इसमें और फीचर्स भी तो ऐड कर सकती हूँ जो आप सबने मुझे बताई थी. Because I have taken only permissions के बेस पे इतना रिजल्ट आया. Suppose if I adding other features, my accuracy will improve. Then I can apply feature selection techniques also. Or other thing, I can change the model. It might happen that with MLP I'm getting this result. And you should always know the reason behind using a particular model. And you should also mention the same in your research paper. Why are you using that particular model? So that was all about MLP and to improve the result. Now I am coming to the last part, That is large language model. That is basically the hot topic nowadays. Everyone is using LLM in each and every field. So have you studied this large language model in this FDP? Have you gone through it? Basics and everything is done? Okay. So large language models. All of you might be using Chat GPT. सबको पता होगा Chat GPT के बारे में. और there are a lot of AI techniques, Perplexity, or Gemini, lot of you will see GPT models are there. So they are basically large language model, DeepSeek, yes. So LLM is trained on massive amount of text data. Natural language processing यहाँ पर आ जाती है. It is trained so that it can understand our human language and it can also generate human language. For example, English to French, it can do. English to Chinese. I remember when during this first year admission, some students were there who cannot write in Hindi language. They opened Chat GPT, and conversion was already there. So this is how we are using everyone. It's in our hand now, in our pocket, smartphones में Chat GPT का application है. So remember, LLM talk like humans. It does not think like human, but it talk like humans, and it read a huge amount of text. You can give it as an input anything. You can give LLM कुछ भी input दे सकते हो, book, website, code, conversation, everything. But I have highlighted code in red color because we are working on malware, and you can see here that during your reverse engineering here, you find you found lot of code. It can be in the form of XML file, it can be in the form of Smiley file, it can be a Java, anything. So you can utilize this in LLM. So these are the files that you can give, and it will predict from that source code whether it's malicious or not. It is also used to guess the next word. I like chocolate dash, chocolate cake, chocolate drink, chocolate coffee. It will guess the best word which will fit there. And how does it work? It breaks your sentences into small parts, token, that is known as tokens. Okay. And transformers are used in LLM. So that is the basic heart of LLM, that are transformers. And how transformers are used, you can see in this diagram. The research paper that has been published using LLM, they have shown this figure that I'm displaying. So it's not mine, it has been taken from a research paper. You can see here in transformer, encoder and decoders are there. What you do, you give some input sequence. What kind of input sequence you are giving to LLM? I highlighted in red color because we are talking about malware only. So you can give input में क्या दे सकते हो आप? Code, any code, your XML, Smiley, Java, or any file, whatever you have. Even if you have that code, obfuscated code. You know about obfuscated? Obfuscation के बारे में पता है सबको? Nowadays, obfuscated code are coming and that is not easily readable. Even if you do static analysis, you won't be able to read it. So even if you give obfuscated code to LLM also, it will work. Okay. You give it and it convert that into tokens. You can see it convert those sentences, those code into tokens. Now after that, positional encoding we will use such that it will arrange very nicely in an order, because earlier it didn't know how to arrange it, what is the exact order. So with the help of positional encoding, it will do. Next comes your encoder part, where your multi-head attention is being used. Now multi-head attention means I am not reading sentence by sentence. That is the part of neural network. But it does. It will read everything parallelly. A big paragraph, it will read. एक साथ उसको read कर लेगा. Even if you give it simultaneously, बहुत सारे codes, it will simultaneously read it together. Single page पूरा एक साथ. So that is multi-head attention. It is giving attention to everything, each and every code, each and every paragraph. Then definitely normalization you can use. MLP linearity के लिए आप जो अभी हमने पढ़ा MLP के बारे में, you can it uses MLP normalization and everything. So this is your encoder part. Then the output of the encoder will go as an input to your decoder. Decoder में everything is almost same, but yeah, we have masked multi-head attention. That is, we put a mask on multi-head attention so that it should not read the next word. अगर उसको पता चल जाए तो फिर वो आंसर क्या देगा मुझे? Okay, so that is masked. Rest everything is same. And in the end, I'm converting that to a linear. Usko, and I'm using an activation function depending on the classification, and you are getting the output. Okay, so this is how it will work. LLM. And here in this session, because I'm showing hands-on of static analysis, your MLP also, and similarly I will show LLM part also. So there are two types of LLM detection, sorry, malware detection using LLM you can do, either manual or automatic. Manual means just copy the code, give it to ChatGPT, ask, is it malicious or not? And rest whatever question you want to ask you can write, it will give you the output. So this is the manual detection. But in automated detection you can use, or you can write a code in a similar way that you have written in Google Collaboratory for MLP, that is multi-layer perceptron. Okay, but yes, using APIs, if you want to use, you can go with that way, or another way is nowadays RAG is very popular, you can go with RAG also. Okay. So what it does, how this using in this session, I'm focusing on APIs. So first thing is we need to extract the code from APK. We already did that using static analysis, that is reverse engineering. Fine. Then obviously there are some dangers, permissions, functions, other lines of code are there. We will feed into LLM, but by using any API. So there are some paid API also and free API also. So you can use, if your institution is sponsoring you with your that seed money, you can use that. And but I'm using here in this session free API, that is Llama 2, because it was free. Nowadays the Llama 4 has also come, but this was free, so that is why I'm using it. And then you can ask some question. For example, what behavior does this app exhibit? Is it malware or not? Generate a label, benign or malicious, plus how confident are you? So this is how your LLM will work. So now I will show you practical of this LLM. Okay. So here you can see on my screen, again I'm in Google Collaboratory, and transformers here I've used, and from transformer I'm importing some libraries that I use here to basically classify whether it's a malware or not. Torch for GPU, OS, RE for regular expression, because natural language processing we are going to use, and we are giving code as an input to your LLM model. So natural language processing will be used and regular expression will be there. Next, the model ID, that is this you have to go to your Hugging Face and you need to log in, and you need to create your own model ID, and you need to mention here that you want to use. Now, next thing is the tokenizer. That is, now what I'm doing is I'm giving a complete input of my source code, but I want to it will convert it into different chunks, that is tokens. So that is why I have called this tokenizer, and I'm giving my model ID here. And here also I've mentioned my model ID and other things. For example, if I want my CPU memory usage to be low, then I can put it true. For GPU usage, everything I have mentioned. Now here I'm giving a folder path, because here you can see that it will take a few time to for the folder to appear here. That depends on the internet connection. But here you will see a folder with the name of content. It is not appearing right now. For example, in my previous file, you see here this files folder. Similarly, a folder will be here. It has appeared. Now, if I go to that folder, if you can go to content folder, you can see that JSON or some other files are there, but I can import or I can put some files here. For example, I can put here my Smalley file. I can put my XML file. So let me put that, upload. For example, this Smalley file I am uploading. Okay. Other I am uploading is, let's say, manifest file, Android manifest.xml. This was the file. So this is how you can upload. In previous neural network mein, I've shown you another way of uploading by writing this code. This button will get enabled, choose file पे जाकर के वो upload हो जाएगा. The other simplest way is go to this folder and upload. Okay. Now here I've given this folder path that in this directory I placed all files whatever I have uploaded. Okay. Now here I'm creating this empty लिस्ट हेयर अबव में तो आप गिवन कंप्लीट पाथ डायरेक्टरी का पूरा फोल्डर दे दिया और फाइल के लिए मैंने एक्सेस दे दिया. नेक्स्ट में मैंने क्या किया है, यहाँ पर इस लाइन में आई हैव मेंशन्ड कि to read all the files that end with XML or Smalley, because if you remember right now I've uploaded Smalley extension जिसका Smalley था और XML. You can add Java files also and other files also. Now y predict is the y, if you remember, that is label predicted by ML model. This is not actual y. Fine. Now here I'm using for loop to read all the files available in the list, and I'm opening that file in reading mode and reading that particular file. Now here I'm using natural language processing where I'm writing this sentence, which is very important in LLM. What are you writing? And according to your writing only, the output will appear. So here I'm writing, you suppose you are a malware analyst, analyze the following code. It could be Android manifest.xml or .smalley, and tell me if it is malicious or benign. Respond with only one word. I have specifically mentioned, do not write the complete story, only mention whether it's malicious or benign. And there is a reason behind it why I have written respond with only word, because for malware, I will write 1, for benign, I will write 0, and this is how I will create a list. Okay. Now, next is your tokenizer. I think I have explained in the theory part that you are giving your code and it will tokenizing it. And if you want to restrict your maximum length, you can restrict it if you think that, okay, the length is greater. And you are uploading the same to some GPU. Next is this is how the model will generate everything. It will generate some tokens. Then here I'm using some regular expression and I'll be searching for the output. I'm searching in the output that has been produced by your LLM model. So model has produced some output. I got the response. Now I'll be searching malicious. If I'm getting this malicious, that is the model is giving me malicious, then I am appending 1 to y underscore predict. What was y underscore predict? It was your list, empty list. Okay. And similarly, else may I have written, it automatically means benign. Else may I have written 0. 0 means benign. So I'm printing classified as benign. In the end, I'm printing the summary. Now you can see here the output. I uploaded Smalley file and this is the complete Smalley code. Okay, and it was classified as malicious, and actually maybe it was malicious. Fine. Similarly, it was analyzing your XML file. You can see here, this was the XML file. These were all the permission that was asked by that particular application. And you can see here, it is classified as malicious. So this is how the list has been updated. Earlier it was empty, now it is 1-1. That is both files that I have uploaded. First one is also malicious, second one is also malicious. Now you know that in the end, you can use this confusion matrix in the similar way I've shown you in your multi-layer perceptron. Fine. And you can match your y true. Y true was the y which was your actual label, and y predicted is this. So you can compare both, and you can get the result accuracy, precision, recall, F score, because I've only given for 2 examples, so it was not good to get the accuracy for only for 2 samples. So you can do it for thousands of samples, and then you can get the output. So this was all about LLM practical. Now, any question regarding reverse engineering, MLP, LLM, you can ask me. Then I'll be showing you some research paper on this. No question, it means सारा सर के ऊपर से जा रहा है. LLM ज़्यादा हो गया. Did you understand जो भी मैंने आपको पढ़ाया LLM का? Okay, you will try. Okay. I think it's a new concept. LLM आजकल काफी nowadays it's very popular. So yeah, even I'm showing you this code. I've not even published a research paper now, LLM. पहले ही मैंने पूरा code आपको दिखा दिया है. So now I'll show you my basic papers on ransomware. LLM पे मेरा पेपर तो नहीं है, but yeah, बाकी authors का मैं आपको दिखाऊंगी. So let me hide it. So this was the paper on static analysis, because in this session, I taught you static analysis. So I'll be showing my research paper to you. So this was my research paper during my PhD. So I told you earlier that I focused on only on a specific malware. You can choose all the 2 or 3 malware, but don't go for generic, go for specific one. And yes, I used unsupervised because whatever research paper I have studied, they all used supervised. Now here in this paper, let me show you the diagram what I did. This is the first see, look for this diagram. What actually I have explained or did practical of my own research paper and show the same to you. APKs मेरे पास था. I took APKs and I got, yes, very important, I got the data set from this paper, Chen et al. And it's a very popular paper. They created their own ransomware, Android ransomware. That is .apk files, raw data set. And I requested them and they provided the same data set to me via email. I again repeat, the raw data set. Then I took those data set and those were ransomware benign I got from Play Store. Then I performed reverse engineering using APK tool, and from reverse engineering I got these folder manifest.xml file, resource folder and dex file. So resource mein I got some images and so on. XML mein I got permission, but dex files were not able to, I'm not able to read it because it was written in some other language or encoding techniques. So because these were Dalvik executable files, just like in Java, you know about Java executable. In Android, Dalvik virtual machine is used instead of JVM. So that is why it produces Dalvik executables. So this was that. So I use another tool, that is dex2jar. So I got the jar files. Then jar file mein I need to get the Java source code. So that is why I got this JDGUI tool. I downloaded it and I got these Java source code. So when I analyzed these files here, you can see this raw data set. I use these 3 tools. Then I did pre-processing. I got this manifest.xml file, resource folder, dex से मुझे jar मिला, jar से Java. Manifest.xml से तो I got permissions and intents, 2 features. From resources, I got a lot of text. What kind of text? See, I got text that was used by cyber criminals to afraid users. For example, if you downloaded, suppose an application, it will lock your screen and a threatening message will appear on your screen that your computer has been locked, you has been charged because you were using some unauthorized applications, and you need to pay $300 bitcoins to this address, then only your computer or your smartphone will be unlocked. So this is how these kind of threatening messages I got in resource folder. And some text was written in images also, and because if it is not written in images ऐसे ही है तो वो detect हो सकता है, but image में है, so it is difficult to detect. So that is why I used OCR, that is optical character recognition. All of you might be familiar with that. It is used to get the text from the image. So वो वहां से text निकाला. So these were the features. Moreover, then I analyzed Java source code. There I got locking features कि locking के लिए कोड लिखा गया है स्पेसिफिकली टू लॉक द स्क्रीन. इंक्रिप्शन टेक्निक्स उसके अंदर यूज हुई हैं to encrypt the data, that is whatever data is present in my smartphone, it will be encrypted by an algorithm such as advanced encryption standard, RSA. So, and yes, some encoding technique has been used because some in a few samples I found text in some another languages also. Mostly I found Chinese text, Russian text, because Russian, Ukraine, दोनों के बीच में war and so on. So you know that a war is happening, so cyber war भी simultaneously is going on. So I worked on different languages also, not only in English. I worked on you can see here Chinese language also. I think I put a sample here. You can see Chinese sample also, Russian also. So I worked on different languages. So after getting these permissions, cleaning everything, put it in nicely in a CSV format, I used unsupervised techniques, and feature selection I used because I had a lot of approximately more than 1000 features I collected. So I used some dimensionality reduction technique also, that is PCA, principal component analysis. Then instead of basic model k-means, I used Gaussian mixture model. Then Gaussian mixture model actually has a flexibility. अगर कोई border पे भी है, it will consider it, but now k-means उसको ignore कर देता है. So it has a flexible that it can expand its cluster. So then it clustered in the form of ransomware or benign. So this is how these clusters were created. So this was all about static analysis paper only, in which only one or two algorithm have been used, no other chains. Okay, so if I go to LLM, so this is not my paper. I downloaded a paper from IEEE Access. So this is LLM Maldetect. That is a large language model based method for Android malware detection. So you can use that. They are also using same functionality, same things that I've shown you here. APK लिया, APK को pre-process किया, code, jar, PNG, XML, whatever they got. फीचर इंजीनियरिंग किया, उसको अच्छे से नाइसली प्लेस किया, मॉडल ट्रेन किया, मैलिशियस और बिनाइन आ गया. एंड ड्यूरिंग एलएलएम यू कैन सी हियर दैट उन्होंने ये डायरेक्ट यहाँ पर एलएलएम को दिया, एलएलएम ने लास्ट में give the output, it is benign or malicious. Same encoding, decoding, everything is automatic. So LLM has given it. Okay, the only thing is permission that they have used are permissions, sorry, features they have used are permissions, API calls, strings, everything they put it nicely and give it as an input to your LLM model. And this is how it worked. And this paper, I guess it got published in the year 2025 only, April. So nowadays, most of the papers are coming in LLM. So that is why I encourage all of you to go for LLM, RAG ko use karo. And if you want to do something in here, so you can definitely use it. So this is all about static analysis, reverse engineering, multi-layer perceptron, and large language model. Now the house is open for question and answers. If you have any question, any discussion, you can ask me. Yes, about PPT, I will share code. I will share. Don't worry about it. Research paper, भी I will share with Vikash sir. I will share everything. Any technical question, any discussion, anything if you want to discuss, you can tell me.
So participants, we are open for the question, and if you have further query, we may discuss that one. Ma'am will address those questions.
So I have also mentioned my email address in the chat box so that you can email your query, and I am also open for research collaboration in this area, malware. If someone is interested to do research, I can definitely collaborate in this area and we can publish or write good research papers. I hope I've not skipped any question in the chat
No,
box.
till now,
Okay.
everything was
Okay.
addressed. So definitely, it would be a great honor to work with you, and definitely the area of expertise you are having. So if someone finds it interesting, they may collaborate to work on this domain. And there are many research scholars who are currently working on this one. So someone is saying something. Do you have research experience in the domain of fast flux networks?
No, that is not my domain. So,
So
yeah.
any more question? I have recently started working on this one, ma'am. So
Okay, on malware?
maybe yes.
Okay,
Actually,
then
I
to,
worked on zero day, zero day earlier in
okay,
my PhD work, but
okay,
zero day and classical machine learning. But now I have switched to this malware. My MTech scholars and PhD are recently
okay,
they are exploring this
okay,
areas. Hope
okay.
if somewhere I require, I will contact you.
Definitely, sir. Definitely, it would be an honor, and we can collaborate also.
No, no, ma'am.
Yeah, yeah.
Definitely, I will contact you. And this is why we conduct FTP so that we can know each other. We can
Yes,
have some collaboration in future.
yes.
So, one quick question is there, ma'am, from Amit Singh. Does
Does the
LLM assisted mal?
LLMs,
Yes, ma'am.
does the LLM assisted malware detection require access to GPU? Is that a yes, definitely GPU though is required, and in Google Collaboratory we have this GPU, some freely available.
So
Access to
even
GPU is required.
exactly, and the malware size when we talk in terms of EXE, definitely that will be huge if you are directly processing
Yes.
them. So definitely you will have to access the GPU. So okay, someone is Nayan Kumar Mali. He is working on
On
hybrid
hybrid.
malware analysis. That's good. Good.
It's good.
So hope to see some kind of collaboration in future. So
Yes,
I
yes,
hope
yes.
with this, ma'am has addressed all the queries. Uh, Actually, explore confusion table is more interesting. Yes, you can go with the confusion table. That will give you more insight into what is happening there. Some question from Lakshmikant Vasishtha sir is there.
Actually, explored confusion table. Yeah, I have explained confusion matrix. No. Okay. So I guess, sir,
So
I have
I hope,
answered most of the
yes,
queries.
ma'am. So participants, so we are now closing for the day, and I hope you have enjoyed the session and got insights from various perspective, like starting from the Android malwares, how they work, what are the critical components on which you can work for the detection model. Okay, then you have gone through this NN networks and then LLM models, how they work, and you can definitely explore further if you want to go for the research in this direction. And if you want to connect with the ma'am, you can connect with any time. Ma'am has provided already the email ID with you. So we are very much thankful for this insightful session, ma'am, and hope to collaborate in future. And thank you so
Thank you,
much
sir.
for giving us the time. And
Thank you.
this so even from what we said from the on the behalf of participants also, I would like to thank you for this
Thank you, sir.
insightful session. and and the amount of question they have basically asked reflects the importance of this session. So thank you so much. Thank you so much.